Welcome to an overview of the RAOB program's Fronts and Forecast module. In the beginning, before the age of calculators, computers, and centralized forecast offices, meteorologists used a variety of manual methods to extract forecast information from sounding data. These methods were developed in the 1930s and 40s and required a series of mathematical and hand-drawn graphical procedures to arrive at a forecast. These methods took several minutes to accomplish and often resulted in different forecasts depending on the person's experience level and available tools. But RAOB has automated these procedures into a few milliseconds of reproducible results, and even though these techniques are truly back to basics, the better your understanding of the four-dimensional nature of the atmosphere, the better success you'll have in creating forecast soundings. But why is this Fronts and Forecast module even needed? Because when the lights go out and communications are down and you no longer have access to the internet or forecast information, RAOB gives you the tools to create forecasts from your last sounding, assuming of course you have battery or generator backup. And with RAOB's Fronts and Forecast module, you have an extremely versatile and powerful single-station forecasting platform. One final note before beginning the demonstrations: this video does not explain the theories behind the forecast methods used. That information can be found in RAOB's optional User's Guide and Technical Manual. Okay, let's get started. First we'll call up a file with a single sounding. Now recall that this module has two functions, Fronts and Forecasts. The Fronts function is accessed from the Displays menu by using the Frontal Analysis option. And the Forecast function is accessed from the main menu's Forecast option. While this video briefly reviews the features of both functions, each function is explained in detail with their own individual videos. Since forecasts are of primary interest, we'll start this overview with the module's forecast functions, and so we'll first select this Forecast menu. The Forecast Sounding Profile option will create forecasts for the whole profile, while the Forecast Maximum Surface Temperature option only focuses on the surface or boundary layer forecast. So let's first forecast the maximum surface temperature. Note that this is a morning sounding with a surface radiation inversion. Also notice that the positive CAPE is 143 and the negative or SIN CAPE is minus 376. Okay, now let's activate the maximum surface temperature function. And notice that the inversion is gone. The old profile is drawn in gray, and the new surface temperature follows the dry adiabat up to the original sounding profile. Also notice that the CAPE and SIN values are now 752 and minus 151. So let's now restore the original sounding, recall the Forecast menu option, and look at this function's configuration settings to see how the maximum temperature was derived. The maximum surface temperature was produced by the gold equal area method of 1933. This method assumes no clouds, light winds, and summer months. However, RAOB has a unique set of user configurable options to fine-tune these assumptions, which are explained in detail in the separate forecast video. So let's again see the maximum surface temperature application. But first, let's apply the CAPE graphic overlay. And now we'll select the maximum surface temperature option and watch the CAPE graphic change. Okay, now let's clear the screen and load a data file containing multiple soundings from the same synoptic time period from across the United States, and where we'll select the Cape Hatteras sounding. And now we'll recall the Forecast menu, and this time select the Forecast Sounding Profile option. And now we see a floating toolbar of forecast functions. There are two modes to this toolbar, single station and multi-station. And they use totally different methodologies. The single station method uses the classic thermal wind theory, where the sounding's wind field is used to only modify the sounding's temperature profile, but not the dew point or wind profiles. The multi-station method, on the other hand, uses upstream soundings from which data are advected and will modify both the temperature and dew point profiles in addition to the wind profile. So let's first use the single station method. Before making a forecast, notice the 5 control buttons. The middle button is the reset or restore button. The single arrow buttons move the forecast by 1 hour time increments, and the double arrow buttons move the forecast by 6 hour increments. Also note that these forecast methods are only intended for short-term forecasts, and even though the controller buttons allow forecast values up to 99 hours, the higher values should only be used for educational or what-if scenarios. Okay, for demonstration purposes, let's click the double arrow or 6 hour buttons 2 times. And now 4 things have happened. First, the forecast hour box reflects the forecast time period. Second, the data listing automatically updates. Third, RAOB interpolates and plots winds at 1,000 foot intervals to better see the wind field, which is also used to make the thermal wind forecasts. And fourth, the dry bulb temperature profile is drawn to reflect the thermal wind forecast, while the original profile is shown in a gray color. Now let's take a closer look at the forecast profile. There are 2 sections which show warming and 2 sections which show cooling. The warming is caused by veering winds and the cooling is caused by backing winds. Now notice that there is an option to maintain the sounding's dew point spread. So let's reset the sounding display and then make another 12-hour forecast, and now we see that the dew point profile has also changed. Also notice that the thermal wind forecast has altered the entire sounding profile. This is called the main layer as defined by this toolbar section. There is also an optional boundary layer section which overrides the thermal wind effects and allows greater control over the mixing layer, giving the user the ability to simulate synoptic patterns and diurnal changes. This section and the other toolbar options that are not discussed are demonstrated in the separate forecast video. Okay, let's move on and select the multi-station forecast option. Remember, this method does not use thermal wind advections, but instead advects data from upstream sounding stations. This, of course, only works if you have a multi-sounding data file with soundings that are upwind of your location. So let's see how this works. First, notice that we've specified a 1,000 kilometer search radius, which found 13 nearby soundings, where 6 of them are upwind of the current Cape Hatteras sounding. We can see these soundings by selecting this View Soundings button. Now we see all soundings within a 1,000 kilometer range of Cape Hatteras, where the upwind soundings are in red and all others are in black, and where upwind is determined by the relative location of the sounding stations with respect to the direction and speed of the Cape Hatteras winds. For example, the upper level will be modified by these stations, and the lower levels will be modified by these stations. You can also see how each data level corresponds to different upwind stations by moving the mouse over the wind of interest. Using simple click and drag actions, you can also manually override which upwind stations are used. Watch as the entire sounding wind profile is selected, so that all advections come from the Greensboro sounding station. And now only the Greensboro dot is red. And if you want, you can further specify that the lower levels instead use advections from the Charleston sounding. But for now, we'll just restore the map to its original settings to make a forecast. And just like the single station thermal wind forecast method, we'll make a 12-hour forecast for comparison purposes. And just like the thermal wind advection method, this upstream advection method also shows cooling near the surface and mid-troposphere, and warming in between. Also notice that the dew point profile and wind profiles have also been modified, as they were adjusted from the 6 upwind sounding stations. And just like the single station method, the other toolbar options that are not discussed are demonstrated in the separate forecast video. And now we'll demonstrate the second half of the Fronts and Forecast module, the Fronts functions, where we've already loaded a new sounding. This time we'll start with the Displays menu and select the Frontal Analysis option. Notice that the display looks very similar to the hodograph. In fact, if we click on this hodograph hotspot, we see the standard hodograph display. And we can now click on the Fronts display hotspot for a quick return. Also notice the sounding diagram hotspot, which when clicked plots the initial sounding profile. And while we're here, let's open the toolbar with a right click of the mouse along the left side of the sounding diagram, which is the shortcut for the Analyze menu option. And now let's select the Frontal Layer option, where we see a cold front boundary in the 800 to 825 millibar range. And notice a corresponding cold front image is also included in the mini hodograph. To get back to the Frontal Analysis display, we could again select the Displays menu and then the Frontal Analysis display. Or we could just click on the mini hodograph like this. And here again we see the same cold front. Along with this blue cold front image is the corresponding wind vector segment, which is also plotted in blue. Additionally, the wind data details are highlighted in blue in the Data Listings box. And the wind plots are also drawn in a blue color in the wind plot profile. Now let's take a look at the fronts table at the bottom of the screen. Here it shows that RAOB found two fronts for this sounding, a cold front and a warm front. RAOB also initially displays the strongest frontal zone, which is defined by the largest thermal gradient, which is listed here. Since RAOB also found a warm front, let's click on this Layer box button to display it. We now see a red warm front, along with its corresponding wind vectors in red. And now when we click on the sounding return image, we see the same warm front plotted on the sounding diagram. And let's open the toolbar once again. And this time we'll apply the inversions option. And here we see a corresponding frontal inversion associated with the warm front. And just below, near the 850 millibar level, we see a subsidence inversion, which is associated with the cold front. Now let's return to the frontal analysis screen one last time with a click of the mini hodograph. And this time notice the frontal data box in the lower left corner. It is a diagnostic analysis of the displayed frontal system. For example, this is an animatic warm front moving at 5 miles per hour towards the east-northeast. It is currently 277 miles to the west-southwest and contains vertical motions of 509 feet per hour. Precipitation is expected in 1.5 hours, where the associated clouds and precipitation are ahead of the surface front. So there you have a general overview of RAOB's frontal analysis functions. But if you view the separate fronts video, you will find much more detailed information about these functions, including the configuration options used to find these fronts. You will also find more information on the manual HODO front interrogation screen for advanced users. And that completes the Fronts and Forecast module overview. Please be sure to see the separate videos on this module's fronts functions and forecast functions. Thank you for watching.